Okay, so get this. Today's deep dive is all about how much information our brains can actually handle. Like, what are the limits of our own processing power?
Fascinating stuff.
Totally. And we're diving into a classic for this one, The Magical Number 7 Plus or Minus 2 by George A. Miller, a 1956 paper, but still so relevant.
Oh, yeah, absolutely. Foundational paper in cognitive psychology really got people thinking differently about how we perceive and remember information.
And you know me, I'm always drawn to a title that sounds a little mysterious. So this whole magical number 7 thing, what's the deal? What did Miller discover?
Well, it's not numerology, if that's what you're thinking.
No, I figured as much. But still, gotta be intriguing, right?
It is. Miller noticed this pattern. The number 7 kept popping up in studies on absolute judgment.
Absolute judgment. Okay, now that does sound a bit intimidating.
It's simpler than it sounds, really. Imagine, like, trying to identify a specific shade of blue just from memory, or a musical note without any context.
Okay, so no comparing to other things, just pure identification.
Exactly. That's the absolute part. And what they found, consistently, was that people hit a wall around 7 items or categories.
So, like, I can tell the difference between 5 shades of blue, but maybe not 10 when they're all right there in front of me.
Precisely. And it wasn't just vision. Miller looked at studies on sound, taste, even our sense of where our limbs are in space proprioception, as it's called. Similar
Hold
looking.
on, really, it's like our brains have a maximum number of things they can keep distinct in our minds at once, across all these senses.
That seems to be the case. Miller analyzed all sorts of data, and that magic number, that 7 plus or minus 2, it just kept coming up as this upper limit of what people could reliably judge.
Wow. Okay, so give me an example. How would this work with something like, I don't know, sound? What kind of experiment would they do?
Well, think about musical tones. There was this study where people had to listen to different pitches and identify them. And guess what? They could only really handle about 6 before their accuracy took a nosedive.
6 pitches, so right in that 7 range. Wild. So if you add more pitches, it's like your ears, or our brains, I guess, just can't quite keep up.
Exactly. There's this limit to how much nuance we can process, how many distinctions we can make right there in that moment of perception.
So interesting. And did they find the same limit with other senses too? Like you mentioned taste earlier. Okay, that's just wild to think about. But now I have to ask, like, why? Why 7? Why would our brains have this seemingly random limit on how much we can handle at once?
That's the question, isn't it? The million-dollar question. And Miller really dug into that, even brought in ideas from information theory to try and explain it.
See, this is what gets me excited. Connecting these different fields, looking for answers in unexpected places. So information theory, how does that fit in here?
Well, the key idea is the bit, right? It's like the smallest unit of information you can have, just enough to make a decision between 2 things.
Okay, so like flipping a coin, heads or tails, 1 bit tells you the outcome.
Exactly. 1 bit, or a light switch on or off. 1 bit gives you the state of the system. Now, if you have 4 possibilities, you need 2 bits to know for sure.
Because you're making 2 of those coin flip decisions in your head to narrow it down? Makes sense. But how do we get from bits to like tasting salt or hearing a musical note?
It's all about distinctions, right? Every time your brain has to differentiate between 2 things, any 2 sensations, it's making a choice. And the more precise that distinction has to be, the more bits of information are needed to make that judgment call.
So back to the salty solutions. If I can tell the difference between, let's say, 4 levels of saltiness, is that my brain processing 2 bits of information?
You got it. It's like your taste buds are sending a 2-bit message to your brain. And Miller's big idea was that our senses, our ability to transmit those bits, it's like they have a limited bandwidth.
Like a data cap, but for our senses. And for basic judgments, it's around 2 to 3 bits, which translates to that 5 to 7 we keep hearing about. That's so cool.
It is pretty neat, right?
Yeah.
But here's where it gets even more interesting. Miller thought maybe this limitation, this constraint, what if it's not a bug, but a feature?
Wait, so you're saying that having limited processing power could actually be a good thing? Now, that's a twist I wasn't expecting.
Think about it. Our early ancestors, right? They were bombarded with sensory input all the time. Sights, sounds, smells. What if their brains tried to process every little detail? They'd be overwhelmed.
They'd miss the important stuff, like the saber-toothed tiger hiding in the bushes making a weird noise.
Exactly. They had to be able to focus on what mattered, make quick decisions based on limited data to survive. It was a matter of life or death.
So our brains evolved to prioritize, to categorize, and make those snap judgments. Fascinating. But still, it seems like we deal with way more than seven things these days, right? I mean, I recognize way more than seven faces, I'd hope. How do we square this whole limited capacity thing with the complexity of, well, everything? So we've evolved to be super efficient with information, even with these built-in limitations. But how does that explain how we operate in the world, you know? Remembering tons of stuff, doing complex tasks.
That's the beauty of Miller's work. He didn't just point out the limits. He said, look, our brains are amazing at finding ways around them. He called them techniques for getting around it and increasing the accuracy of our judgments, but it's like our brains have these built-in workarounds.
Workarounds. It's like our brains have their own IT department. So what kind of tricks are we talking about here?
Well, one is what we call relative judgment. Instead of trying to identify things in isolation, our brains are always comparing. Like, think about describing a color. Right?
Easier to say it's like a brighter blue than that one rather than like, give me the exact shade from memory.
Exactly. We use context. Our brains grab onto any extra bit of information to make sense of things. And another trick, we chunk information together.
Ah, chunking, like with phone numbers, right?
Exactly. Or faces. You're not processing 7 different features.
No.
You see the whole face as one thing, one chunk of information. And Miller found evidence for this too.
Oh, really? How so?
There were studies where they gave people sounds that varied in a bunch of ways, like how high or low the pitch was, how loud it was, that sort of thing. And even though their capacity for each individual aspect was still limited, people could handle more overall when it was bundled up in a meaningful way, like different dimensions of the same sound.
So it's not just about the chunks themselves, but the relationships between them. Like we're giving our brains a bigger picture to work with, even if the number of pieces is limited.
Precisely. And then there's how we process things over time, sequentially. We break information down into smaller bites rather than trying to take it all in at once.
Like learning a phone number. You don't memorize the whole thing in one go, you chunk it up.
Exactly. Or think about learning Morse code. It seems impossible at first, but you start with those little dots and dashes.
Then you build them up into letters, then words.
And eventually, your brain's processing whole sentences as one fluid chunk. Pretty amazing, huh?
That is really cool. So there's a name for this whole process, right? Transforming information into something our brains can actually use.
Miller called it recoding. It's like our secret weapon for breaking through those limits, taking those little bits and turning them into these bigger, more meaningful chunks.
It's like organizing a messy room, right? You take all that clutter, those individual bits, and you sort them into boxes, label them. Suddenly, it's not so overwhelming.
Love that analogy.
Right.
And the more we learn, the better we get at recoding. Experts in any field, they can recall incredible amounts of information because they've built up these incredibly dense, well-organized chunks in their brains. They're the masters of recoding.
So it's not just how much we know, it's how well we've organized that knowledge in our minds. It's the connections, the structure we give it. That's kind of empowering, right?
Absolutely. It means we're not stuck with these limitations. We can work around them, learn more, understand more deeply. It does make you wonder, though, are there limits to recoding itself?
Right. Like, is there a point where it's just too much, even with the best organization?
That's the million-dollar question. And honestly, Miller's paper doesn't really answer that. He thought maybe there's a limit to how many dimensions we can handle, even with recoding. But more research is needed for sure.
Well, this paper was published in 1956. Surely someone's picked up that research ball and run with it by now, right?
Oh, absolutely. This paper was huge. I mean, it basically launched a whole new field of study cognitive psychology. People are still exploring these questions today.
Wow, so Miller really got the ball rolling on understanding these fundamental limits and how our brains find ways to overcome them. It really makes you appreciate the power of the human mind.
It really does.
How?
It shows that even though we might have these limitations on how much we can process at any given moment, our capacity for learning and adapting, that's practically limitless.
It's a great reminder that we're always learning, always evolving, and that the more we explore and understand those limits, the more we can push past them. So keep those brains engaged, everyone. Keep asking those why questions and see where they lead you. That's all for this deep dive. We'll catch you next time for another fascinating exploration of the human mind.